Now we're going to use this relationship between derivatives and integrals to analyze graphs. So you're given this graph of two line segments, this graph f. So this is graph f. I'm going to write that in. This is the graph of f. We're saying, okay, well let g be the function defined by g of x equals the integral of this graph of f from 0 to x, whatever that x is in this g of x. So now our first task is to find g of -1, g of 0, and g of 2. So let's start with g of -1. We're just going to use this formula right here and this graph of f. So g of -1 equals the integral of 0 to -1. Uh-oh, going backwards. We'll have to rearrange that. Okay, of f of t dt. Okay, so remember the rules of integration say that if you're going from this lower bound to an even lower bound, that's the same as the negative of -1 to 0 of f of t dt. So now we just need to find the integral of this graph from -1 to 0. And that's when x is -1 to 0. So x is -1 right here, and x is 0 up here. So we're looking for the area of this triangle, which is, let's see, height of 1, 2, 3, half of the base, so 1.5. So this equals, don't forget about this negative 1.5. And this is g of -1. So now I'm going to clear this so I have room for g of 0. Alright, so let's find g of 0 now. Equals the integral of 0 to 0, nice, of f of t dt. Why did I say nice? Well, from x to x, 0 to 0, that's just a point. What's the area of a point? 0. Great, now let's do g of 2. So this is the integral from 0 to 2 of our graph f right here. So this is, let's see, 0 is up here, all the way to 2 is down here. So we're looking for the area of this whole, right, yes. This whole thing. Okay, so keep in mind that if an area is below the x-axis, that has a negative integral value. So that means this area right here is 1.5. This area down here, if you count, we got 3 plus 1.5, so 4.5. So this integral value is going to be -4.5. So then we add those together to find the total integral from 0 to 2 of this function f, and that is -4.5 plus 1.5, which is 2, -2. Sorry, -3. Whew. Yes. So that is g of 2. All right, now let's take a look at these g primes. Okay. So g prime, I'm gonna write this to the side. I'm gonna take this over here. So g prime of x is the derivative. Oh, sorry. Let me actually write an equal sign so that it makes some sense. Okay, g of x equals, g prime of x equals, the derivative with respect to x of the integral 0 to x f of t dt. Okay, this looks a lot like that fundamental theorem of calculus, because it is. So this just means that g prime of -1 equals the derivative of the integral is just this thing. So it's just going to be f of 1. Sorry, of -1. So just find the value. So let me erase this. F of -1. What is the y value when x is -1? 0. So now let's find man, I just can't get this marker right today. Alright, let's find g prime of 0. This is, again, going to be f of 0, which is up here, 3. Last one, g prime of 2 equals f of 2, which is equal to -3. So that's how to find these g primes. Now let's find second derivative of g. So if you can kind of see the pattern here, first we start with the integral of f, then we got just f. Now it's going to be the derivative of f is the second derivative of g. Yeah, I'm just going to clear all of this here. And we're going to slide down the page. So this was the integral of f. This is just f. This is going to be the derivative of f. So this means that g double prime of -1 is going to be the derivative of f at -1. So remember, the derivative is the slope of the line. So a -1 here, what's the slope of this line? Rise over run, 3. Now let's find the derivative at 0. So second derivative of g of 0 is the derivative of f at 0, which is the slope of this line, the slope of the line at this point, which is it's a maximum, so it would be 0 here. Now we'll take a look at 1. So what is the derivative of this graph at 1? That is right here. That derivative is -3. All right, last one. Just joking. We have 2. Okay, for what values of x in the open interval, -2 to 2, so just what is shown here, is this graph of g increasing? Not when f is increasing, when g is increasing. So remember that to find when something is increasing, that's when its derivative is greater than 0. So our next question has to be, well, what is the derivative of g? That is shown up here. Remember, we did it here too. The derivative of g is f, is the function f. So let's see. Let me write this over here. So g is increasing when f, its derivative, when f equals g prime is greater than 0, is positive. So when is this f positive? So our interval is from -1 to 1, which is from -1 to 1. And our next one, our last problem, for what values in this interval, -2 to 2, is the graph of g concave down? Remember that concavity deals with when the second derivative is positive or negative. Concave down is when the second derivative is negative. So g is concave down when the second derivative of g is negative or less than 0. Sorry, those are supposed to be a regular little g of x. Now, let's relate this to our graph f. So g is concave down when g prime of x is less than 0. And remember that g prime of x is a derivative of f. Or sorry, g double prime of x is the derivative of f. Oh my goodness. F of x. So now, let's go up to this graph. Remember that g is concave down when the second derivative is less than 0, or, so that it means in our graph when the first derivative is negative. Which is just when our graph has a negative slope, which is from 0 to 2. So which is, here I'll write this in parentheses, from 0 to 2. By the way, I don't know if I've mentioned this, but this is a way to write intervals is with parentheses and brackets from 0 to 2. So this case right here, the 0, 2, is not a coordinate, it's an interval from 0 to 2. You could also write something like 0 is less than x is less than 2, or you can just use words to describe it. Yep, so that's your reasoning. This is using this for the fundamental theorem of calculus to analyze graphs, and just really the relationship between derivatives and integrals. So that's it for this video. Email me with any questions that you have. Yeah, and I hope you have a good week.